I'm going to make this public. Why did I make it private? No reason to. Let's see. And there's Pamela. All right, now we'll get started here. Let me take a drink of coffee. All right, let's get started.
Recording in progress.
Well, welcome everybody. How's everybody doing this morning? Nice to see all the regulars. Everybody doing good? Happy? Doing well? All right. Oh, I got some fun stuff today and Thursday, and now we start getting into more of the really fun stuff. But first of all, I want to mention NANOG, North American Network Operators Group. NANOG is an association, nanog.org, that I belong to. They actually have all kinds of cool stuff, and I'll share more of this with you another time. Who are they? They are all the mostly a lot of ISPs, internet service providers. These are all the network engineers, network analysts. These are also some of the people anybody connect that, basically anybody that's an autonomous system. Some of the content providers are out there. A lot of people followed by, anybody that's really into network operations at that level. So they just had their meeting. Where was it? Anyway, and the keynote was somebody I've been following for a long time, Jeff Houston. Jeff Houston is he's the chief scientist for the Regional Internet Registry in APNIC, Asia Pacific. He's from Australia. He's been involved in this since the early 90s. He is the one that helped get Australia onto the internet. Anyway, he gave the keynote, What Happened to IPv6? I put this on and I'll put the links on Canvas. I'm a little bit behind on this. But really what this is about is the evolution of the internet and IP addressing over the last 35 years. How it evolved and where it is today and where it's going. And he gives a great perspective on all this. He's the one that does all these IPv4 charts, like, how many routes are in the internet routing table, where all globally IPv4 allocation throughout the world. He's been doing this stuff for decades. Always an exciting, great presenter. If you really want to get a feel for the evolution of the internet and how IP addressing has evolved, great presentation. And what's really cool is, especially if you've taken my 81 class where we talk about content delivery networks, a little bit about Anycast and things, this is what he's talking about. This here is a tutorial. This is from guy from IPv4 Global. Which reminds me, I owe him something, a little blog he wanted me to write. But anyway, I'll get to that someday. And he gives IPv6 familiarity training. Basically, he's going to catch everybody up to speed on IPv6 in 2 hours. Yeah, I think he goes a little fast and doesn't cover things but anyway, what's kind of cool is, watch this, and you'll be like, hey, you could be sitting in that crowd and going, yeah, I know a lot of this stuff already. Here's a talk about how Facebook internally in their data centers removed IPv4. So even for IPv4 packets, it uses, and I'll talk about this at another time. Basically, all the addressing is just IPv6. And it can route for both IPv4 and IPv6, but when it gets an IPv4 packet, it says, oh, the next hop is an IPv6 address. Well, how does that work? All it needs is the MAC address, right? How is it going to encapsulate that IPv4 packet into an Ethernet frame? So anyway, we'll talk about that at another time. But what I thought was really interesting about this is one of the things he says, we had no choice. One of the things he says, we burned through a public/21 address. So, how many hundreds of thousands of addresses is that? Public addresses every 3 months. So he said, we had no choice but to go to IPv6. All right, let's get started. Any questions on that? Now I'll post these. This is really the one to watch. All right, so today, and I'm talking to you from home. I mentioned this, I think, earlier. I'm going to a cousin's funeral after this, so I'm going from home to the funeral and back to school. So,
sorry about that, Rick.
Oh, thanks. I appreciate
My condolences.
Oh, thanks. Yeah, it was, these things happen in life, and it's important for me to be there. So, let's see. So here's the so I'm at home right now. Here's my IPv6 addresses that I'm showing. Now you see these deprecate. What in the world is that? We're going to talk about that on Thursday. Okay. I get a lot of these at home where I hardly see it at Cabrillo, and we'll understand why. Actually, we're going to introduce the why today. But I'm getting all my addresses from our IPv6, and it's all using something called stateless address auto configuration. So let's come back to that. Let's get going on the router advertisement. So first of all, the way addresses, or really any kind of service, networking service, is both can sometimes be categorized as either stateful or stateless. Stateful is when a server is keeping track or a record of the interaction. Okay, TCP is a stateful service. It keeps track of who got what packet, of what segments, what's missing. We're going to be getting into that this week in my 81 class. Network address translation is a stateful service. Okay, private IP address to public address, and also looking at the port numbers. DHCP for IPv4 is a stateful service. And that's what we're going to get to in a moment. Stateless is no one is keeping track of this kind of information. And this is how stateless address auto configuration works for IPv6. We're going to get into that. More than that, then we'll talk more about stateful DHCP v6 at a later date. But DHCP for IPv4 is a stateful service. Okay, so basically the message is sent over UDP. There's no guarantee. There's no three-way handshake, no acknowledgement, just sends it. Okay. So what happens is the client sends out a DHCP discover message with no IPv4 address saying, hey, basically any DHCP servers out there, because I want to join the network and I need IP addressing information. A DHCP server will send out a DHCP offer. That's why we call it DORA, by the way. The discover, the O in the offer, and then you'll see the request and the acknowledgement. This is offering an address and also subnet mask, default gateway, things like that. The client will usually accept the first offer it receives. So usually it's only one because there's usually only one DHCP server out there. So it will say, yes, I request that offer that IP addressing that you're offering me. And the server will then say, okay, I'm acknowledging that this is all yours. And I'm binding this specific client IPv4 host address that I'm giving you to your MAC address. And I'm keeping track of that state along with a lease time, how long you have it for, and that sort of thing. It's a stateful service. All right, so this is DHCP for IPv4. So basically, all that information there is, this information here, by the way, is stateless. The subnet mask, default gateway, DNS server information. When the DHCP server gave that information to those two devices, it didn't care about, it gave the same information to everybody. But the specific IPv4 address PC1 and PC2 got came from a pool, and that's unique, and that is stateful. So it kept a record of which of these devices, based on their MAC address, got which IP address. Okay. Now they both are getting IP addresses from the same network. Okay, but what they're getting is different host portions. Okay. Any questions on that? I'm not going to get into DHCP here for IPv6 yet. We're going to get into IPv6 next in general. All right, so that's IPv4. The only service it has is stateful, or you can do static addresses. Let's take a look at how it works for IPv6. In IPv6, a router sends out an ICMP v6 router advertisement message. We're going to look at this in detail today, what that actually looks like. We're going to look at it, what it looks like in my home. Or from my home router, we're going to see what it looks like from my school router. Okay. Now, that can be sent out periodically. And how often is that sent out periodically? Depends on the router. We'll talk more about this, but for example, at school, Cisco routers send it every 200 seconds. So what is that, every 3.5 minutes? Do I have my math right? Where here at home, my Comcast router sends it out every 3 seconds. We'll talk that has some different way of doing things, and we'll learn more about why Thursday. Okay, now a router advertisement message can also be sent anytime a device sends a router solicitation message. Your device does this when it joins the network. Okay, either wirelessly or wired. Plug in that cable, or you open up your computer, connects to the access point, it sends out a router solicitation message. Then the router will respond with a router advertisement message immediately. Let's take a look at what's in that router advertisement message. First of all, the destination IPv6 address. It's a multicast address. It's what we call that well-known multicast address. Remember, FF is multicast. The 2 means link local scope. Meaning if there's any other routers out here, don't forward this. The double colon 1 means this is for all IPv6 devices. So if you're enabled for IPv6, you've got to listen to this. Now the source address is coming from its link local address, not its global unicast address. This ensures, as we'll see in a moment, that when these devices use this address as their default gateway, it ensures it's on the link because it's a link local address. It's only good on the link. Okay, what's included in this router advertisement message? And we're going to look at the real router advertisement messages in a moment. It advertises what network prefix everybody's on. So the router goes, my global unicast address is on this network. So I'm going to advertise this network prefix. I'm going to advertise a DNS server address for you. Now, also got 3 flags that can be set: auto config, other config, managed config flag. The auto config flag is what we're going to focus on today. This is the default on Cisco routers. This means that the device is going to create its own IPv6 address. We'll see that in a moment. So what happens is these devices get the router advertisement message. They say, great, I know what network we belong to. That's really cool. It says, oh, the source IPv6 address of the of the router advertisement came from FE80:1. You must be my default gateway. I'll use that. DNS server, great. I know that. I know who to ask when I type in www.youtube.com. What's the IPv6 address for that domain name? Okay. The auto config flag is set. Okay. Well, notice everybody got this information here. When the auto config flag is set, okay, means it's using Slack, stateless address auto configuration. Key word in that is stateless. Also, the word auto configuration kind of helps as well. All right, so what does that mean? That means that these devices are going to take the network prefix, first 64 bits, and create their own 64-bit interface ID. Okay. No stateful DHCPv6 server needed. Now, in our case, we used random interface IDs. Okay. We'll talk more about that too. Okay. Does that make sense so far? How are we doing? Okay. Cool. I love it when we start moving along in this, start like a lot of repeating, a lot of seeing this again in different ways, because you're already learning more than most people know about IPv6. If I say most people, I mean most people that work in IT. All right, let's delve into this a little bit more. So global unicast address, yes, you can configure it manually on the device or dynamically using stateless or stateful addressing. Slack is stateless. DHCPv6, yes, there is stateful for IPv6, stateful DHCPv6. We'll talk about that later. All right, so we talked about the router advertisement message. So this is actually part of what's known as ICMP v6. Similar to ICMP for IPv4, except more stuff added. And this is the stuff they added. They added router solicitation, router advertisement messages. This is for router to device messaging, like the router advertisement message, router solicitation message, which we'll look at in more detail in a moment. Later, we'll look at neighbor solicitation and neighbor advertisement messages. This is for things like any device to any device messaging, like for ARP. I know your IPv6 address, what's your MAC address? We'll get to that later. And there's also something called a redirect message. I'll mention this later, but it's similar to what we do in IPv4. All right, so just to remind us, multicast. These are the two multicast, well-known multicast addresses we're going to be using. The all IPv6 devices and all IPv6 routers. Yep. The all IPv6 routers is what a device uses when it sends a router solicitation message. Yeah, Pamela.
I was just wondering, in the past, didn't we always assign the router the number 1? So why would they switch it now to, am I missing something or am I over?
No, that's a good question. So this isn't a multicast address. So this is not a specific address on a router. This just means all routers.
Okay.
So they chose, so this means all routers will listen to this. So we're not assigning it, but the router will, once a router is enabled to route IPv6, and we'll see this in a moment, it will listen to this address. That'll make sense in a moment. Okay, so on the client configuration, for IPv6, it says, it doesn't say IPv4, it doesn't say use DHCP. Okay, it says obtain an IPv6 address automatically. If we look over here on my Mac, for IPv4, it says, automatically use DHCP. Oh, for IPv6, I don't specify DHCP. I just say automatically. Why is that? Because we're going to see the router advertisement makes the determination. It all begins with the router advertisement. The router advertisement, which is sometimes abbreviated RA. It suggests to clients how they should receive their IPv6 addressing information automatically. Okay, so if you're going to do it automatically, this is my suggestion based on the information I'm giving you here, especially with these flags. Now, it's a suggestion. Operating systems can always do whatever the heck they want. Okay, and by the way, they follow all the client OSs by default will follow whatever in the router advertisement. We want to play nicely on the network. These router advertisements are sent periodically by the router. Okay, or when it receives a router solicitation message from the host. So for Cisco router to start sending router advertisement messages, you have to enable it with IPv6 unicast routing. We saw this last week, and we'll see it again today. But on a Cisco router, you have to use this global configuration command, IPv6 unicast routing. You can configure the router with IPv6 addresses. It just won't do any routing, and it won't send a router advertisement message until this is configured. And it's at that point, by the way, so Pamela brought up a good question. It's at this point the router says, oh, I'm a member of the all IPv6 routers multicast group. I mean, I'll accept anything for FF02:2, the all IPv6 routers. I'm now a member of that group. Okay, we're going to look at some of the options here, because you notice we have these three options right here. What are the options that a router can give? Okay, there's really three options. One is Slack, meaning I'm everything you need, so auto configures yourself. That's the A flag. The O flag is used with the A flag. When the O flag is turned on, we say set to 1. We'll see these in a moment. It's actually a flag. We'll see this. I'm going to actually show you. It's a bit. By default, these bits are zeros. Okay. By default, this A bit is a 1 on Cisco iOS, and these are 0. That means 1 means it's set to on. When the A flag is on and the O flag is on, the other config flag, I'll talk more. Don't worry about this right now. We'll get to that later. That means configure your own address, but also get other information from a stateless DHCP-v6 server. We'll talk about that later. When the M flag is on, that means use a stateful DHCP-v6 server similar to a DHCP and IPv4. We're going to talk about the O and the M later. So we're going to focus on the A flag today and Thursday. We'll talk about the O and the M flag later, although you'll see them, because when I show you my Comcast router advertisement, what I get from Comcast, there's a lot involved there. All right, so this is just showing the defaults, Cisco defaults anyway. On is the A flag, off and off. And we'll talk about these more later. The A flag, when set to on, says, hey, create your own address. The O flag just means, the O flag doesn't mean create your own. The O flag, well, I'll talk about the O flag more later. The O flag just means get other information. The O flag has nothing to do with you creating your own IPv6 address or getting an IPv6 address. It just means get things like a DNS server address. So really getting an address is either the A flag, which you created, or the M flag, you get it from a DHCP server. All right, so what we're going to look at here is option 1. This is the default on Cisco iOS for sure. All right, so what we have here is it's sending out a router advertisement message. Again, the multicast address is all IPv6 devices. Your client, because it's enabled by default for IPv6, your client operating system, it's going to listen for these messages. Now, we'll see how that actually works, even with Ethernet involved in a moment. Got some good stuff. But right now, just think it's an IPv6 packet in an Ethernet frame. We'll take a look at the Ethernet frame later for all IPv6 devices. Notice your devices already have a link local address. It says I'm sending it from my link local address. Here's the network you belong to. Here's the DNS server, the auto config flag. I think I showed all this stuff before. Yeah. So the A flag, in this case, the A flag is set to 1. So with the A flag set to 1, what this means is create your own IPv6 address. You're going to use the prefix that I sent you, and then either use EUI64 or create a random value. Okay, but no DHCP v6 servers involved. So let's dive into this a little bit more. Okay, so first of all, this is what it looks like. You can do an IP on a Cisco router. You can actually see the some debug called debug information. I set IPv6 unicast routing. Debug IPv6 ND. ND means network discovery. This is going to show you anything to do with ICMP v6 neighbor discovery, router advertisement, router solicitation, neighbor advertisement, neighbor solicitations. So sometimes you get a lot of information. Yeah, I can even at the break. I'll show you right now because it's kind of cool to show this stuff live, right? So I'm going to do here. I'll show it to you live right now. Oops. This is how I got to log in. Okay. Enable. I'll type out the whole thing. Okay. I'm going to use a debug command. Debug shows you processing, input, output, things that are coming in and out of the router. But you've got to be careful with it in a production environment. You never want to do like debug all or debug IP packet. A lot of stuff you can look at. Oh my goodness. The reason is it can overwhelm the CPU with information. So I'm going to do debug IPv6, and you're going to see I've got a lot of stuff I can look at here. And I'm going to do ND for neighbor discovery. You're going to see a bunch of stuff coming here in a moment. Oh. Okay. I had to do that command to send the debug output to SSH. See, all this is a lot of stuff going on. Is that? See, there's a lot of this neighbor advertisement stuff. I'm going to set this over here for a second. So what I'm looking for is the router advertisement. So this gives me some information about what interface it's sending it out of. Here's the source IPv6 address, sending a router advertisement. It sends, we won't worry about this. I'll talk more about this later. Here's the prefix it's sending. The A flag is set. Okay. All right, let's see if I got any router advertisement messages yet. So it sends it just got one. So let me all here. Okay. So I'll show you what happened. I typed undebug all. I could just say undebug IPv6 ND, but undebug says turn off all debugging. Here's the router advertisement message I got. Sending a router advertisement to, this says I'm sending it to, sometimes they change a little bit on their, what the output actually looks like depending on the operating system. But it says I'm sending a router advertisement. I'm sending it to the all IPv6 devices multicast group. Okay, sending it. Here's the MTU. This here is the prefix that would be sending me at school and says A flag. Address auto configuration flag, create your own address. All right. Close this. It's gonna time me out anyway. All right. So, creating your own address. How do we do this? We don't need a DHCP-v6 server. How do we create this, our own interface ID? We've got the prefix. Okay. Well, we can use EUI64, which makes it a known address. Okay, we know what that's going to be. We can figure that out. Or a randomly generated number. Okay. So the default, most clients are now defaulting to randomly. Cisco iOS, because it doesn't care about privacy, defaults to EUI64. You can change this in your operating system. Let's remind ourselves of EUI64. Okay, it takes the 48-bit MAC address, okay, shown here in 12 hexadecimal digits. We have the vendor portion and the device identifier. Split that up, insert 16 bits in the middle. We go from 48 bits, now we've got 64 bits, what we needed. Okay, but we're not quite done yet. We have to take that 7th bit, see it here in blue? It's called the universal local bit, it gets flipped, which ends up changing the second hexadecimal digit. And that's our interface ID, the host portion of our address when we use EUI64. All right, so let's say we send out the router advertisement message here, okay? Again, sending it out to all IPv6 devices from the source IPv6 address, it's like local address. Here's the prefix. Here's the DNS server address, and use the A flag is set. So create your own interface ID. Okay, great. Network prefix, we both did that. Source IPv6 address, there's our default gateway. DNS server, great, we have that. Now let's create our own global unicast addresses. PC1 here is using EUI64. So there's its MAC address, and it just inserted FFFE in the middle, flipped the 7th bit, which changed the second digit here from an 8 to a C. Okay, but it's using the MAC address. That's why, by the way, the link local address was also. So usually what's done for one is done for both. And for a link local address, it really doesn't matter because it's not used off the link. Now down here, this device, its operating system says, I'm going to use a random 64-bit value. So we can see it's up to the client operating system which one they want to use. Okay. In both cases, we did not use a stateful DHCP v6 server. Okay. But one operating system, the client operating system said I'm using random. The other client operating system said I'm using EUI64. Okay, so verifying, again, whenever you see FFFE in the middle there, you can pretty much determine that was, used by using EUI64. And you can verify it looking at the MAC address. By the way, why 64 bits? Well, it falls on a 32-bit boundary, better even on a 64-bit boundary for 64-bit or even old 32-bit CPUs. Better processing. Also, there is something that there is a specification, IEEE specification. I don't think it's ever going to go anywhere because it's been out there for 30 years for a 64-bit MAC address. But I don't see it ever going anywhere because you'd have to change everything. Think of all the Ethernet switches out there. All right. So there are some concerns about using EUI64. What if my operating system used EUI64? Okay, look at this. No matter what network I'm on, it's the same interface ID. Okay, makes it really easy to track this device. Okay, and you can even track it to the specific network interface card, physical. You're actually tracking it to the physical device in this case, but definitely the same user, no matter where this user is in the world. Okay, so this is a concern over using EUI 64. Okay, so what we like to use is a random generated value. And this is what, let's see, am I at home here? Yeah, this is at home here. So actually, I can show you this here as well. Right here, show it to you live here. So you can see here at home, this is my, and all I got to do is count. This is my network 1, 2, 3, 4. That's the network I'm on. So you can see all my addresses start with that. And here is the random portion. Actually, this is the one. Let's find the one I'm actually using right now. This is the address I'm using right now, is this address here. Now, why that one? Okay, well, first of all, it says temporary. They all say temporary, okay? But these also say deprecated. We'll talk about that later. This temporary address is only used for so long. I love how Comcast does this. We'll see this starting today, that Comcast lets me have a new address for well, we'll talk more about this today, but every 5 minutes, it's telling me you can use a new address if you want. That's why these are all getting deprecated. Okay, but this is 1, 2, 3, 4. So this is my random value, which is only good for 5 minutes. Now, put it this way. After I end my connection with all of you on Zoom and stuff, this address won't be used again for any new connections. We'll talk about that. But this ensures privacy, okay? That my interface ID, what you see right here, is constantly changing. Not constantly meaning as I'm during my connection, like right now on Zoom, it's not changing. It changes when I initiate every so often, when I initiate a new connection with a new server, going to Google, going to Netflix, going wherever, going to Zoom. Hey, new connection, we're going to use the newer address, the newer interface, the same prefix, but with a different interface ID. All right, we'll talk more about that later. Okay. But IPv6 does allow for multiple global unicast addresses. Like I said, we'll talk more about that later. AutoConf, that means it was configured with Slack. My device automatically configured this. All right, let's talk a little bit about, you're seeing on here, so to you live here, you're seeing some that says AutoConf secured and some that says AutoConf temporary. Now notice my AutoConf secured, I don't see anything deprecated by that. Yeah, I have a second one here, we'll talk about that another time. But see this address right here? This is my permanent address, okay? We'll talk about that. Also known as a public address, but I don't want to get the term public confused with public IPv4 because this is publicly routable as well. Let's go down here. The difference, this one says temporary, this one says secured. Let's talk about the difference. I have 2 addresses I can use, okay? Whenever I initiate communications, first of all, they're both going to have randomized interface IDs, the last 64 bits, okay, which is not traceable, okay? Now, the generation of my temporary address this is a relatively short lifetime, hence the word temporary. Okay. And that's going to be determined how long that's good for by the router advertisement. We'll see that in a moment. But this is used when I originate connections to Zoom, to Facebook, to LinkedIn. So whenever I initiate, which is mostly what we do, 99 point, if not 100%, 99.9999% of most of us are acting as a client. We seldom, if ever, act as a server. So I'm using this temporary address, which will change periodically. And that's how the server will see me, based on my temporary address. If I want to act as a server, then that's when this client could use my more permanent address that is least likely to change, if at all. Okay. So I can use that for when I'm on the outside. Let's say I want to connect to my computer at home, and I have to permit it through my firewall. It doesn't just happen. But yeah, that way I don't have to worry about that IP address changing all the time. How are we doing? Good. All right, let's do this. Let's take a 5-minute break, and then we're going to see how Ethernet gets involved. And remind Rick to start the recording. All right, let's do 5.
Recording stopped.
We'll do 8 minutes.
Recording in progress.
All right, we still have a few seconds. I started the recording just so I wouldn't forget. Thanks, Pamela. And I think we're good. It doesn't beep at me.
I have a question.
Yeah.
So how much of this can be used to uniquely identify a computer, like for someone who does something bad? You know,
If they're using EUI 64, okay.
Say in the court of law, they say, well, your your computer was logged into this router because we figured out your MAC address converted to this value, so it must have been your
Sure,
computer.
yeah. Well, I'm not a lawyer, but yes. Can you trace using EUI 64 at least technically, say that most likely came from your MAC address? Yeah, but that's why most client operating systems do not use EUI 64. They use a randomly generated value. Now, in a company, however, organization, you want to, most likely, many organizations, they want to track what IP address belongs to which device, for various reasons. But there they may use DHCPv6, just like IPv4 does. So they can actually say this IPv6 address came from this physical device. So it's just a matter of, at home though, you probably don't care.
So did you SSH into your router?
I did.
And what program were you using? What?
I use, for SSH, I use it's called, I have a Mac.
Yeah. And
a Mac does not support PuTTY, or any of those old ones. So I use something called ZOC, Z-O-C.
Okay, thank you. Did you
Good
know
questions.
the new M4s came out?
Yeah. I would like to get one.
They were very quiet. They were very quiet about it.
Yeah, they're not cheap. My iPhone's an iPhone 8. That tells you.
Oh, wow.
I gotta get an iPhone too. All right. Well, not this tangent. They're too big now. I like smaller phones. Okay, I'll go off on that tangent. All right, let's talk a little bit about the MAC address, and then I'm going to show you some router advertisements and see how far we get. I'm not going to rush this. Got plenty of good stuff here. So, IPv6 multicast to Ethernet multicast. So,
restart your recording.
Yeah, I'm recording.
Okay.
Thank you, Roger. Appreciate that, my friend. Thank you. Never, by the way, any of you, never feel free to always say, are you recording? Okay, at any time. I wish there was something that came out and hit me on the head when I wasn't recording. Okay, Ethernet NIC cards. Okay, but what do they accept? An Ethernet NIC card is to accept Ethernet frames with a destination MAC address that, belongs to the Ethernet MAC the NIC card, burned in address, the physical address, associated with that NIC card. Okay, that's usually what we think. Oh, yeah, but we also think about, broadcasts, which IPv6 doesn't use, by the way. All right. Anything else? Yes. Even in IPv4, by the way. And these are multicasts. Now, as far as IPv6 goes, when your device receives an IPv6 packet, and if that destination IPv6 address is FF01:1, all IPv6 devices, your NIC card is now going to accept, actually, not because of this. Let me restate that. Your operating system is enabled for IPv6. So what that means is it's telling your NIC card, accept any multicast MAC addresses that belong to this MAC address. Any destination multicast MAC address that is 3333, then all zeros and a one. What that is an Ethernet MAC address associated with the all IPv6 devices, well known. Oh, let me do it this one. Here we go. This one right here with the two. All IPv6 devices multicast address. Now, notice I have a 1 and a 2. This is for interface only. That's only for self-testing. This is what we're going to be getting from the router. So your NIC card will now accept any destination MAC addresses, not just for its unicast, not just for the broadcast, but for this specific multicast address. Now, there's others we'll be taking a look at. There's another one, too, well known, which is the well-known multicast address for multicast DNS. So your Ethernet NIC card will also set MAC addresses for this destination MAC address. Okay. Now, why is that important? We're going to see in a moment. That's what the destination MAC address is for the router advertisement message. That's right here. This multicast, all IPv6 devices, which devices would not accept this Ethernet frame? Well, any device that's not enabled for IPv6. All your client devices are, but you may have some web cameras out there, maybe some printers. It's all these types of end devices that are a little bit problematic with IPv6 because they don't support them. Some do, but some don't. So anyway, it's similar to a broadcast in that respect. All right, so let's take a look. This device here, this router, is going to send out a router advertisement message. Let's take a look at what it looks like. Okay, so it's going to send it out. Here's the devices. This is actually one from my home. The ICMP v6 header. This is an ICMP v6 message. It's a router advertisement. We'll see what this actually looks like. But this is where we have things like, hey, this is the network prefix the network that you're on, and the A flag is set. That's encapsulated in an IP packet, IPv6. The destination IPv6 address in the IP header is the all IPv6 devices. The source IPv6 address is this router's link local address. Okay, so my Comcast router did not go out of its way it made it a little bit more, longer. Didn't make it easy for me to read. This is the IPv6 packet, and encapsulated in the data is an ICMP v6 message. Okay. Now, all of this is data. Okay, we have the IPv6 header followed by the ICMP v6 header. This is going to get encapsulated in an Ethernet frame. Okay, the source MAC address is going to be the MAC address of the router. That's what's sending it out of. Okay, the destination MAC address is going to be the all IPv6 devices MAC address for Ethernet. So it's basically says you're sending it to all IPv6 devices. Okay, I'm sending it to all IPv6 devices, the IPv6 header. So my destination MAC address when I send this Ethernet frame out is going to be the special multicast address for Ethernet for all IPv6 devices. Oh, okay. And then there'll be a type field. By the way, this type field means IPv6 is the data, IPv6 packet. And that gets sent out. So all these devices, as long as they are enabled for IPv6, their Ethernet NIC will accept this. And then they will pass the information off to, I'm carrying IPv6. They'll hand the data off to IPv6. And then we'll see IPv6 looks at it and says, oh, hi, here, ICMPv6, why'd you take a look at this? Okay, so this is what the router advertisement looks like. What do I have here? Oh, I know what I'm talking now. 30. So how did they go from FF02:1 to 3333 all zeros and a 1? Okay, so there's the Ethernet MAC address. There's I put out all the zeros here. The IPv6 multicast address. There's a mapping that occurs. So what Ethernet does is they say, okay, we're going to take 3333. I'm going to talk about that. There's a little fun trivia I'm going to share with you. We're going to use 3333, the first 16 bits. And then we'll grab the last 32 bits for the MAC address, will be the last 32 bits from the IPv6 address. Let's just take all these zeros and a 1, put all these zeros and a 1s here. Of course, it makes the colons differently in a MAC address. It's every 2 hexadecimal digits. But it says, let me just grab these. I have them underlined, put them here. That's the MAC address associated with this IPv6 multicast. Let me say that a different way. Multicast addresses, okay, will always have a mapped Ethernet MAC address to them. They'll begin with 3333 for IPv6, and then it will grab, and we'll see this more on Thursday and more each week. We'll see examples of this all the time. In this case here, it grabs the last 32 bits from the IPv6 multicast address. This is what's right here. And says, okay, that'll be the well-known Ethernet MAC address. Now, so that's where we got 8 and 8 is 16, and 8 plus 8 plus 8 plus 8 is 32. A lot of people, that's getting into the weeds a little bit, but there is an association, a mapping between these. They're not just random. There is a mapping. Now, here's the fun stuff. Why 3333? Who came up with that? Really some cool trivia here. So why that 333333? Xerox Park. The address is 3333 Coyote Hill Road, Palo Alto, California. Not too far from where we live, or where many of us live. Okay? So what's Xerox Park? Let me tell you what Steve Jobs said back, happened to him in December 1979 when he got a tour of Xerox Park. Steve Jobs says, and they showed me really 3 things, but I was so blinded by the first one that I didn't even see the other 2. Which 3 things did he see at Xerox Park in 1979? Okay, he saw object-oriented programming that they were working on at Xerox Park. He says, I didn't even see that. He says they were working on Ethernet, local area network. They had 100 of these Alto devices all connected up with Ethernet. Remember, this is 1979. The IBM PC hadn't even been released yet. Okay? He says, but this is what blinded him. He saw a graphical user interface on something called the Alto, with a graphical user interface and a mouse. He says he was so blinded by this, he never saw the other 2. And if you want, there's some interesting little videos on Steve Jobs getting Tourette. I'll get the links here. I'll put them in Canvas as well. And here he's talking about it. He talked about this back in 1994, 1995 is when this was made. Here it is, if you ever want to go there. Here's 280 Page Mill Road. 101's up here someplace. This is Palo Alto. Xerox Park is right here. You'll actually get off 280, take Page Mill, you can take Coyote Hill Road, and then you can go right in here to Xerox Park. It's now called SRI. What else is around this area? You may be interested. VMware is right here. Tesla, well, it used to be their headquarters. They moved to Austin, but Tesla's still there. If you followed the Theranos story, okay, they're right here. It's now Stanford Medical Center thing, but they're right here as well. The building is. So if you watch any of the Netflix documentary or any of the stuff on the news or where they showed the headquarters and stuff, that's right there. There's a bunch of, and all this area. Sand Hill Road is above there. You got HP. You got all kinds of stuff going on. Okay, just wanted to, I don't know. I get that. I find this stuff cool. Let's take a look at what this looks like. You know what? Let's do this. I'm going to show you. I'm going to run Wireshark. Start Wireshark here. So right now I'm seeing everything that's coming in and out of my NIC card, which is like taking a drink from a fire hose. Okay. So what I've done is I'm going to I tell them just look at router advertisement messages. Look how often they're coming. Right now, I'm just looking at ICMP v6, the router advertisement messages. This is the time here. 2 seconds, 5 seconds, 8. Every 3 seconds, I'm getting a router advertisement message. Let's stop that. Let's take a look at what we've got here. I'm just going to take this one here. Let's look at it. Should we look at it live? Do I have? We got the same thing. Let me move this over here if we need to. I've got it right here. Okay, so Ethernet. Let's look at the Ethernet frame. By the way, the way you look at these things, Wireshark, see these little arrows here. Let me make this nice and big here. See these arrows here? Okay. So when down arrow, I see the Ethernet header. Destination IPv6 address. Look at that, 33.33.0.0.0.0.1. And we know why it's that. It's a multicast address. This is the MAC address of my of the router. And it says I am carrying IPv6. 0x means this is hexadecimal values. 86DD means the data is IPv6. Now we can look at the IPv6 stuff. Yeah, let's just look at it in here for a moment. This is the IPv6 header. Version, first 4 bits, version 6. Okay, we got some other stuff here. We'll come back to this here in a moment. This is the source IPv6 address. This is what my device is going to use as its default gateway. Matter of fact, I'll show you that that's what it's using as its default gateway. I did this command on my Mac. There's other ways I can look at it just by looking at the GUI but anyway, here's my default gateway. Okay, where did it get that from? Source MAC address. The source IPv6 address of the router advertisement. Here's the destination IPv6 address. Well, the well-known multicast all IPv6 devices. Let's come back up here. It says, what is the data that I'm carrying? So first of all, after Ethernet was done, it said, hey, IPv6, this is for you. So this was de-encapsulated, the Ethernet header is de-encapsulated, and now we have just the IPv6 packet with the data it's carrying. So IP's looking at all this information. Okay, yes, I'm an IPv6 device. Oh, great, let me grab this, this is going to be my default gateway. Who am I going to hand the data off to? Oh, the next header is ICMPv6. So the IPv6 header will get de-encapsulated, and now we're going to hand off the data to ICMPv6. Look at this stuff. Pretty cool. Okay, so what do we have here? So type code fields. Remember, in ICMP, the type in the code field, type is what designates what kind of ICMP message this is. Type 134, code 0 is a router advertisement. Okay. See here, let's see. Do I want to, I'm going back and forth whether I really want to just show this here. Okay, showed all that. I think it's easier to show. You can see everything right here. Okay, but I'll show you on the real one as well. Okay, so ICMP v6, we said that this is a router advertisement. There's some flags here. Now, my Comcast router also uses the manage and other configuration flag. They want me to get multiple addresses. We'll talk about that at another time. Okay. Here's the prefix information. They're telling my device, this is the router advertisement, telling my device, this is the network that you belong to. Okay. And by the way, this is what I'm showing. I just did this on Wireshark. Okay, prefix information right there. Okay. So I'm not hiding anything, not creating anything, not doing any magic here. This is real stuff here. Tell my device, this is the prefix you belong to, the network you belong to. Great. See this flag here? A flag has been set. See that one there? That means address auto configuration flag that says, hey, use Slack. Okay. So that means that you're going to use that prefix to create your own address. Use this network. And then however your operating system wants to create the interface ID, do that. Okay. And how long is this going to be good for? Wow. So this is very different than Cisco IOS. We'll talk more about this on Thursday and again more on Tuesday. But it says, your address that you create is only going to be good for 5 minutes. Okay. Unless you're still involved in a connection, okay, then use it until the connection ends. But you won't create any new connections with that address after 5 minutes. It's only good for 5 minutes. And is that okay? Well, we'll talk about that. Remember, I'm getting a new router advertisement every 3 seconds. So we'll talk more about that. So, anyway, very different than Cisco. I like this. It means, boy, the chances of somebody following me, my privacy at home, very, very good. So here is the DNS server address for you to use. I'm giving you 2 of them. Okay, so when you type in www.zoom.com, ask one of these servers for the, it will give you the IPv6 address for that domain name. How we doing? There's other stuff here we're going to talk about.
Rick, it's a lot, but you said in the past it's okay that it feels like it's a lot. It will absorb.
Yes.
Okay.
Yes.
Thanks.
Yes. Yeah. You got to remember, this is your first exposure. I don't know if I mentioned this, but I have a very good friend of mine who used to be the senior network analyst at UC Santa Cruz. Very big in the world of networking, belonged in analog, did all this, all this high-end, big networking stuff. Anytime I gave a presentation on IPv6, he would show up. And I asked him, he's my neighbor. I said, Mark, why are you always coming? He goes, Rick, I need to just keep on hearing this. He says the first couple of times it just, it's new. And I said, yeah, I get it. I'm the same way with anything I'm learning. So, yes, it's just repetition and seeing it in different ways.
Thank you.
Mm-hmm. Let's see where we are here. How much? Oh, yeah, I got one more slide, actually. And I'm going to hold off on that slide. And what I do want to show you is a little bit more. Let's go back to this router advertisement and let me shrink it a little bit. Yeah, so this is the router advertisement messages. This is everything your device needs to know. Now you see some of these things that are open here or are closed that I can open. But yeah, it's just, again, your device, just to kind of make sure we understand it or help us understand this. That source IPv6 address of the router advertisement. Let me bring this down right there. Okay, this is what my device is using as its default gateway. Let me bring that up. There you go. I'll show it to you like this. This is the router advertisement being sent by this router, right? You can see it right here, the white box. This is its source IPv6 address. And if you notice this, my device said, oh, you're my default gateway. Okay. And you can see I created all these addresses. I didn't. My computer did. My operating system did. Okay. Now, how did it create those addresses? In the router, in the ICMPv6 message, which is a router advertisement. Let's go right down here to prefix information. And it says, this is the prefix right here. See up here, it's giving you, see this up here? It's giving you a summary of what's below it. But it says, this is your network prefix. And this is your prefix link. So it's telling my computer, use this network address, use the first 64 bits is the network portion. 1, 2, 3, 4 hex tens. Okay, that's what my computer did, so I'll use that. It says also, use this as your DNS servers. Okay, so it's all there. The only thing my computer, and oh, let's go one more place. So how should my computer create its address? Okay, what it's going to do is, oops, there. So in that same place where it gave us the prefix and prefix length, it said the A flag is set. This is all suggesting to my computer. It says, I'm giving you everything you need. I've given you your network prefix, telling you the first 64 bits is the network. I'm telling you, just create your own, however you want to do that. MAC address, UI64, or random. My computer, my operating system says, I prefer to do random. Okay. All right. And I've got the IP, and I've got the default gateway. And I've got the DNS server information right there. So I'm good. I've got everything I need. And you told me you're my default gateway, right? Yep. Where's that? Right up here. Source address. It's all here for us, ready for my device, ready to use. And the only thing that was sent out is these router advertisement messages. In this case, every 3 seconds from my router. No DHCP server. And it says, and I'm not, and by the way, nobody's maintaining state of who has what addresses in this case. Okay? It's this, in using the A flag, we'll get to the M flag, the DHCP v6 stateful server later. But it says with that, hey, you create your own and nobody's keeping track. Okay. So, which is fine for homes, small businesses, maybe even companies, maybe even businesses. Android phones, I wouldn't say notorious, but Google, we'll get that. They only supports Android only supports stateless address auto configuration. That's been a issue between Google and many others. So there's somebody at Google thinks, one person that kind of thinks they know best. I'm not, no judgment on my part, but there's many people that they do not support DHCP v6 on their phones. All right, how we doing? I think we're going to end it here. And just kind of, not to recap, but just to kind of remind us what we just looked at here is just really this here. Yeah, so, this is what we looked at. And then these devices can use this prefix length, and create their own graphical user interface. Global unicast address, GUA, their own global unicast address. They have the DNS address in here too that they use to get resolved domain names to IPv6 addresses. Here's their default gateway, right here, default gateway. And this is what my computer uses. Okay. There's no network address translation. There is for IPv4, but not for my IPv6. This is how, right now, Zoom is seeing me and sending packets back to me. I'm sending my packets to Zoom using that address. It's sending them back to me using that address. Is this beginning to make sense? Yeah. So, you know, it's always the first look. So it's very, this is different than IPv4. Okay. All right. So you're actually, you know, well ahead of the curve of many. And, you know, I liked seeing the Nanoid presentation on, you know, IPv6 familiarity training. He goes over things real fast and just kind of talks at things. I wouldn't say it's real trading. There's some good stuff in there, but you know, it's one of those things. If you've heard it before, what would be kind of cool about this is when you look at this, watch this, you'll see, I could be sitting in this audience and following this. Okay, same thing with here. And same thing with here. It's, you know, there's a lot of good stuff here as well. This is a great presentation. I'll put this on Canvas. All right, I'll let you go. Have a great week, everybody. I'll see many of you tomorrow in class.
Thanks, you too.
Yeah, take care, everybody. Good seeing you. Great questions. Take care, all.
Recording stopped.